GridGuard Spain. On 28th of April of 2025, Spain suffered a real blackout that lasted around 16 hours and affected up to 25 gigawatts of demand. Red Eléctrica Española's official post-mortem shows the warning signs were there hours in advance: stream renewable penetration, falling synchronous inertia, a progressive worsening supply-demand balance. But there's a catch: grid frequency, the most direct signal, isn't published by any public API. Red Eléctrica Española withheld it for operational security reasons. This project asks, can a multi-agent system, working only with what's publicly available, catch that kind of situation in time? Why agents? GridGuard combines three layers of intelligence, each only where it's actually needed. Pure Python for what's deterministic, machine learning to detect statistical patterns, an ensemble of an isolation forest, an LSTM autoencoder, and a calibrated classifier, and a Markov chain projecting where the grid is heading. The LLM only steps in when real reasoning is needed, synthesizing signals, checking regulations, deciding how to escalate. This principle is called shift left, and we applied it retroactively too. When we found the LLM wasn't reliably following the escalation policy, the fix wasn't improve the prompt. It was taking the decision away from the LLM entirely and handing it to a deterministic Python function with 17 tests, 6 layers, plus an offline layer underneath. The ML models and Markov chain train periodically, not live, and a monthly Chrome drives a real agent, the research agents that draft new knowledge for our knowledge base. A human has to approve it first, only then does it get embedded and stored in ChromaDB, our local vector store, for the reg layer to retrieve. Layer 0 triggers kick off the runtime cycle. Layer 1 is pure Python functions, no LLM. Between every layer from now on, small hook callbacks blocking secret files, rate limiting, sanitizing prompt injection, validating every output. You'll see them as we scroll. Layer 2 is 5 custom MCP servers, grid data, weather, memory, ML models, and RAG over Red Eléctrica Española and ENSOE regulations. Layer 3 is skills, synchronous agent tools with one structured result each. Layer 4 is sub-agents with their own loop. One drafts report, another evaluates cross-border imports. Layer 5, the orchestrator, decides how to escalate. Right after it, a reliability layer that runs after every LLM turn. A deterministic functions recomputes the escalation policy and forces any mandatory steps the model skipped, so a single LLM mistake can silently break the response. And cutting across everything, an eval framework. Every agent checked on three axes: trigger output trajectory, offline and against real Gemini, and a model registry, so no Gemini model is ever hard-coded anywhere. All of this runs locally. We didn't deploy it to the cloud for the reasons of cost and time. In production, the infrastructure would change, not the agent's logic. The README has the details. Now we proceed with the demo. This is exactly what a cron job would trigger every 10 minutes in production. I'm just firing it manually now for the camera. I'm feeding it the real Spanish grid snapshot from the hour before the April 2025 blackout, and the orchestrator decides on its own with real Gemini. It normalizes the data, consults the ML ensemble and the Markov chain, computes the risk band, and decides which agents to escalate, with no intervention from me at any point. There it is. High severity, 12% blackout probability, Markov state S2, which means a stressed grid, and the model explains itself. Reserves are completely exhausted, renewable penetration is at 100%, which pushes out synchronous generation and drops the grid's inertia, and a wind ramp down is forcing a negative balance. That combination is exactly why it escalated to the anomaly detector, and exactly what escalation planner or deterministic policy, not the LLM, dictates for that band. GridGuard Spain was built with Google ADK 2.3.0, Python 3.14, and Gemini, following spec-driven development as the working framework. Every feature got a written spec and implementation plan, and execution with independent review at every step. These folders are the paper trail. 8 specs and 13 plans, not just code that works. When live validation reveals unexpected LLM behavior, we corrected each issue with evidence and documented it on these files.